Greetings to all. I am Janathan Murali, and my supervisor, who is guiding and who will be guiding throughout my project, is Dr. Nancy McLean. My research topic is Effect of Growth Regulators on the Micropropagation of Grape Breeding Line. And in the upcoming slides, let's see why the growth regulator is very important in the micropropagation of grapes. In this slide, let's see about importance of micropropagation in grape. Grape is one of the important commercial crop growing all over the world for table purpose, wine preparation, and for raisins. In Canada, grapes are grown in provinces like Ontario, British Columbia, Quebec, and Nova Scotia, mainly for wine preparation and for table purpose. In Canada, grape industry contributes about $9 billion annually. Grapes are mainly propagated through vegetative propagation method like softwood cutting, hardwood cutting, layering, and grafting. Sexual method of propagation is not preferred due to the great genetic diversity of the grape species. Even in conventional propagation method, there are many disadvantages like seed dormancy, cutting dormancy, space and time conservation, and reduced yield. So, propagation of grapes through tissue culture is one of the potential solution to avoid losses in cultivation of grapes. The type of growth medium and growth regulator used will determine the success of the tissue culture in any plant. Out of many researchers conducted, modified MS medium, modified by changing the concentration of manganese, chloride and iodide salt concentration, proved to be efficient than the original MS medium. Best example for modified MS medium is Chien Pool C2D medium, developed especially for grape micropropagation. The growth medium I am going to use in this research is oral medium and half strength MS medium. Oral medium contains reduced salt concentration than the MS medium and it proved to be efficient in trifolia micropropagation. So I'm going to compare the efficiency of oral and MS medium in the micropropagation of grapes. So the main aim of this research is to find the effective growth medium and the growth regulator. Right, let's see about tissue culture in grapes. Plant tissue culture is a science of growing plant cells, tissues or organs isolated from the mother plant. Plant tissue has the ability to grow in artificial medium provided the suitable cultural condition. This ability of plant can be potentially exploited in the tissue culture. Annually, more than 50,000 varieties of plants are produced commercially through micropropagation, and most of them are ornamental crops with very few vegetable and fruit crops. But the micropropagation of woody plant species like grapes is increasing rapidly due to its efficiency and rapidity. Grapevines can be easily propagated through tissue culture. Tissue culture in grape is mainly used for clonal propagation and germplasm conservation. Application of tissue culture in grape gives rapid multiplication, disease-free, high-yielding, and true-to-type plants. In this slide, let's see about importance of growth medium and growth regulator. Success of grape tissue culture mainly depends upon the growth medium and growth regulator. Composition of growth medium determines the growth of plant from its plant material. As I mentioned earlier, modified MS medium by reducing the salt concentration like G and pole medium or half strength MS medium proved to be better than full strength MS medium. As oral medium is also modified MS medium with reduction in salt concentration. We can see that in these pictures. This is the amount of salt to be added for preparing 1 liter of solution. This is the salt concentration for MS medium and this is the salt concentration for oral medium. Here we can see the amount of ammonium nitrate to be added for 1 liter solution, which is 1.65 gram, and in oral medium it is 0.5 gram, and for potassium nitrate it is around 1.9 gram, and for oral medium it is around 1.05 gram, and for magnesium sulfate it is 0.37 gram, and it is for oral medium it is 0.106 gram. So oral medium is more or less equal to MS medium in salt composition but with reduced concentration. As there are many research suggests that reduced concentration of MS medium proved to be better in grape micropropagation. I am going to use oral medium as culture medium to compare the effectiveness between the MS and oral. At the same time, plant growth regulators also play an important role in determining the shoot proliferation and root growth. There are several researchers involving Grape micropropagation is proved. BAP is suitable for shoot development and IBA is effective in root development. But the concentration of this growth or growth regulator varies according to the varieties and breeding lane used. So it is important to determine the effective growth medium and the optimum concentration of growth regulator to achieve the successful tissue culture in grapes. Next question is, will the oral medium be effective in micropropagation of grape when compared to half-strength MS medium? The reason for using half-strength MS medium is, as I mentioned earlier, half-strength MS medium is better than the full-strength MS medium and it is proved by many researchers. And my second question is, will the concentration of 1 mg per liter or 2 mg per liter of indole butyric acid and benzyl aminopurine gives the effective growth of root and shoot in micropropagation of grapes? And my objective of the research is to employ the combination of different concentration of growth regulator, which is benzyl aminopurine and indole butyric acid, for the micropropagation of grape breeding line grown in two different medium, which is half strength MS medium and full strength oral medium. My another objective is to find out the optimum concentration of growth regulator and the effective growth medium for the micropropagation of grapes. In many research, 2 mg per liter of IBA and BAP use the better growth of root and shoot, but it varies depends upon the variety. Hypothesis: I predict that if the effective growth medium is used for micropropagation of grapes, then the successful plant culture can be obtained because growth medium contains all the essential nutrients required for growth of the plant. And also I predict that if the optimum concentration of auxin, which is indole butyric acid, and cytokinin, which is benzyl aminopurine, is given in the micropropagation of grape, then the optimum root and shoot growth can be obtained because auxin and cytokinin is responsible for root and shoot development respectively. Let's see about methodology in this slide. The first step is preparation of culture medium. In this step, all the required macronutrients, micronutrients, and the growth regulator stocks will be prepared for both the MS and oral medium. The second step is sterilization of the culture medium and culture tube. This step is very important to avoid microbial contamination in the culture. The third step is transfer of explant for shoot and root proliferation. The fourth step is determination of effect of BAP on shoot proliferation, and it is determined based on the parameters like shoot length, number of days taken to shoot, and the number of shoot. The fifth step is determination of effect of IBA on root development, and it is determined based on the parameters like root length, number of days taken to root, and the number of root. Uh, in this in this picture, we can see the developing shoot from the culture medium in the first tube, and we can see fully developed shoot in the second culture tube. And in the third picture, we can see developing root in the rooting medium. Let's see about statistical analysis in this slide. The different variable will be number of days taken to shoot and root, length of shoot and root, and number of shoot and root. And independent variables are concentration of growth regulators used, which is three different concentrations of indole butyric acid and benzyl aminopurine, and the type of salt being used, which is half strength MS medium and the full strength oral medium. In this first picture, we can see the different concentration of BAP used for shoot development. Here we can see three different concentrations, which is 0 mg per liter, 1 mg per liter, and 2 mg per liter in two different medium, which is half strength MS medium and full strength oral medium. In the second picture, we can see three different concentrations of indole butyric acid in two different medium. And the experimental design. Completely randomized design will be used as experimental design. All the collected data will be examined using one-way analysis of variance to find out the significance difference among the treatment. 6 number of treatments will be used for shoot proliferation experiment including control, and 6 number of treatments will be used for root development experiment including control, and the six number of replications will be used, which gives the sample size of 36 for shoot proliferation experiment and the 36 number of replications for root development experiment. Here comes the conclusion slide. If the oral medium is effective than MS medium in the micropropagation of grape, then oral medium can be used as growth medium in place of MS medium. If the applied concentration of IB and BAP gives effective shoot proliferation and root growth, then it can be used for micropropagation of this breeding line. Next, impact of this research. If the oral medium is effective in micropropagation, then it can be used as new growth medium and it can be tried as growth medium for tissue culturing of other plants as well. If the effective growth regulator concentration is found, then it will be very useful for the rapid multiplication of this grape breeding line through micropropagation with higher success rate. Thank you for listening. Take care and stay safe. Bye.